Hi, welcome back everybody. This is part 2 of the world's fastest RC10 build. Okay, I'll show you what I've done up till this point. Made some changes here. Went back to the ribs up front. Nice and light. Got some better bearings in there. These are actually the bearings that came with the RC10. So they spin and they just keep spinning. Tires wobble, or the wheels wobble a little bit, but they don't wobble up and down, so I don't think that's going to throw off, I don't think they're going to bounce at speed, I guess is what I'm saying. Up front here, I actually I lowered the spindles, or dropped the spindles a little bit with the spacers, so I can get that ride height nice and low. When it's weighted down, it's going to be right on the ground. I have, as of right now, just a ½ ounce of lead on the front bumper. My first run's only going to be to hopefully about 60 miles an hour, so we'll see how it handles. I want to see how light the front end feels, especially with these tires. These are lighter wheels up front. And then I can add weight. I can add more weight later. I chose the power plant for my project here, and it came in. I went with the Castle 1406 series. Just came out. It was actually on back order. I had to wait for it to come in, but it's got the 4-pole rotor. It's supposed to have more torque, so I could go with the nice high RPM motor and still have some decent torque. This one is a 6900 kV. I'll explain why I chose that one later. This was actually a pretty involved decision. But still lots of torque, and 6900 is a pretty hot motor. Just one down in this series from their fastest one. Okay, yeah, and there it is. Kind of a strange thing. On their website it says the maximum speed limit is 66,000 RPM or 65,000, something like that. On the motor it says 100,000 RPM max, but it also says a 2-cell Lipo maximum, which doesn't get you anywhere close to 100,000 RPM with a 6900 kV motor. So I'm not really sure what that means. I think they're kind of saying, hey, the rotors can probably handle 100,000 RPM, but use it at your own risk with the higher cells. And I might just do that. So, because I think I'm going to have to. The Mamba Max Pro ESC did not fit under the body. This is my old body. I was just testing it out, cutting through there. I think the first few runs are going to be with the old body, just so if I'm flipping and skidding across on the lid, I don't scratch up the brand new painted body. So I cut it out so the cooling fan can, you know, vent the heat and stuff. I hope it doesn't catch too much air in the body and hurt anything, but I think it should be fine. I'll show you what I got going on under here. Okay, I have the motor wired in. They give you these kind of long leads for the Mamba Max. I have them twisted to reduce radio interference, and I'm just using the factory Castle connectors here. We'll see if those heat up much and see if that's going to be a problem. I'd rather not cut and shorten the wires just yet, because the wires going into the speed control are hardwired to the circuit board, so you can't really change them out very easily. Okay, over here, oh yeah, I have a soldered on a Dean's lossless connector. If anybody out there knows a better way to solder these, let me know, because this thing is all over the place. Before the solder melted, actually these wires came pre-tinned. Before the solder melted, the whole wire was just super hot, and I'm using a 700-degree soldering gun and everything, so that shouldn't have been the problem. But anyway, hopefully these are a nice plug and work well. If not, a pain in the butt to solder. What I'm going with here, This I foresee is something that may need to be upgraded. This is the Airtronics, using the MX3. Here's the radio. Nice radio. I actually picked up the new Sport, there we go, the 2.4 gigahertz Sport Airtronics, and it doesn't feel anywhere near as nice as my existing MX3 FM radio. So I sent it back, and I'm sticking with this one for now. We'll see how much range I get. That's the other thing. Range on FM radios, I don't know. I have to test it out, but I don't want to run out of range. And if the car's doing 70 to 100 miles an hour, it's going to run out of range pretty quick, I think. So we'll see if that becomes a problem. I may need to get a 2.4 gigahertz system, but as far as right now, I like the feel of this one, so I'm sticking with it. Plus, in the radio, I can set up progressive steering rates and throttle rates, so I can have it steer like at high speed. You don't want this. You don't want a slight move of the wheel to throw the thing into a spin. So you can have it steer very, very slowly in the middle and faster on the outsides. So that's what I'm going to do. So yeah, there's the receiver. Have it all wired up. Standard servo at the moment. We'll see how that works. Okay. Well, here's what I've got. I've improved my program here. It calculates battery for me now as well, just for ease of use. But here over on the speed calculator, see a KV rating of 6,900. My first run's going to be voltage is 7.4, 2-cell Lipo, transmission 2.6, drive wheel circumference, pinion. I'm starting with a 23 tooth pinion and an 81 tooth spur gear for my first test run. I'm leaving frictional losses and tire growth at 0 because I actually want to find what those are going to be at that speed, so I can estimate what they might be at higher speeds. You can see my no-load motor RPM at 51,000, effective motor RPM, yeah, 51,000. My effective RPM would lower based on frictional losses and tire growth, but we'll put those numbers in later. So you can see that my drive wheel RPM will be about 5,500, 5,600 almost. Top speed should be 61.78 is what it says, but it's actually going to be lower than 60 because of frictional losses and drag. So that's what I'm going to find out. We're going to do a speed run with that and find out what the speed actually comes out to. Then I can see how much loss there actually is. I'm going to be using a 5,000 milliamp hour 2-cell Venom Lipo with I think 40C, so it's plenty of current for this motor. So the current restriction won't be a problem. Over here, yeah, you see my battery calculator. It's giving me maximum amp delivery of, or continuous amp delivery of 200, so that should be fine. I don't think the motor's going to pull more than that with that gearing. And then over here is where I enter my data. So each run I make, I'll log the data down, put my gearing, my measured speed with either GPS or radar, and then I can calculate my losses. That way I can estimate them for the big run at 100 miles an hour. Alright, well, thanks again for watching. I will update you more as I go along here. I might have, the next video actually might be a test run, so stay tuned.